Alright guys, welcome to this page of the notes, and what we're going to do is we're going to continue simplifying nth degree radicals. In this case, now we're working on our first one that's not a square root. We have a 5th degree radical in this case. I know that because my index is 5. Now, before we start doing these problems, I'm going to show you something, maybe draw your attention to possibly something that you recognized already. But if you didn't recognize this, in the first couple of example problems we did, I'm going to point it out to you now. It's going to save us a ton of time and allow us to actually really just kind of fly through simplifying these radicals. Let me show you it by quickly jumping back to the previous page of the notes where we simplified a couple of radicals, right? So what we did on the previous page here was I had you guys simplify these two problems. Now I did it by writing out a ton of steps, okay? Actually, and hopefully maybe what you already recognized. If you didn't, you'll see it here in just a second. But what is actually going to happen is as long as the index, right, and the power are evenly divisible, you'll just go ahead and divide them, and that will give you your final answer. Let me show you. My index is a 2, right? My power is a 4, right? My index is 2, my power is a 4. Well, what is 4, the power, divided by 2, the index? Well, 4 divided by 2 is 2. Any surprise I wound up with a power of 2? Shouldn't be. That's how it works. Let's check this one down here. I have something to the 8th power. My index is 2. Is 8 divisible by 2? Yes, it is. 8 divided by 2 is 4. Any surprise, I wind up with a final power of 4. Shouldn't be. That's the sort of shortcut version to simplifying these radicals. You just take the power, divide it by the index, and as long as they're evenly divisible, we're going to get these nice simple answers very, very quickly. When they're not evenly divisible, I'll show you what to do. But for now, let's jump back to this page of the notes where we're going to work on this one. My index is 5. I have a power of 20 and a power of 25. Just so happens both of those are divisible by 5. So let's go ahead and get our answer real quick here. First thing you're going to need to do is using your calculator, right? I'm asking you to take the 5th root of 243. So we're going to take the 5th root of 243. We're going to take the 5th root of a to the 20th and the 5th root of b to the 25th. Sorry, I apologize. I'm squeezing. Actually, here, I shouldn't do that. Don't squeeze. Here, I got you. Right down here. We're going to take a 5th root of 243. We're going to take a 5th root of a to the 20th. And we're going to take a 5th root of b to the 25th. Okay, so what we're going to do is I need to find some number, right? Remember the way this works. The 5th root of 243 is going to be some number that when it's raised to the 5th power gets me 243. Well, we go ahead and try a couple of these. If you do 3 to the, I did a couple on my calculator real quick. This one, if you do 2 to the 5th power, so if I were to start with 2 to the 5th power, 2 to the 5th power, if you put that in your calculator, is 32. 3 to the 5th power is 243, which is exactly what I was looking for, right? And again, the way that works on your calculator is if you have the TI-84, you just simply put in your base, a 2, and then you have a power button. It's over on the far right-hand side of your calculator, right underneath of the directional arrows. It looks like a little greater than symbol, it's a greater than symbol that's pointing up. That just means your exponent button. So what that'll do is if you do 2 and then that exponent button right underneath the directional buttons, it'll move your cursor into the superscript position, into the exponent position. You can plug in a 5. So 2 to the 5th is 32, 3 to the 5th is 243, which is exactly what I'm looking for. So what that means then is the 5th root of 243 is 3. Oh, actually, this is great. You should practice this on your graphing calculator. Again, if you go into, on the far left-hand side of your calculator, there's the button that says Math on it. Again, this is on the TI-84. There's a button that says Math. You go into that math function, into that math table, and it's either going to be option number 4 or option number 5, probably depending on what version of the TI-84 you have. And it'll be a radical where they allow you to plug in what you want the index to be, right? So you find that function again. It'll be the 4th or 5th one down on the list. Make your index 5. Take the 5th root of 243. Just hit enter on your calculator, and your calculator will tell you, oh, the 5th root of 243 is 3. Now our shortcut is this. Remember, we take our power, divide it by the index. Divided by the index, 20 divided by 5 is 4. So what you would wind up with, yeah, a to the 4th. And 25, that's my power, divided by my index, well, 25 divided by 5 is 5. So I wind up with a b to the 5th, and my final answer is 3a to the 4th, b to the 5th. Awesome little shortcut, really makes these problems go fast, especially if the power is evenly divisible by the index. Let's go ahead and try another one. Okay, so here we go. I'm taking a square root. Let's split all this stuff up. I'm going to be taking the square root of a negative 16, a square root of x to the 4th, and a square root of y to the 8th. Great review going back to chapter 4, where we talked about this idea of taking square roots of negative numbers. Previously in Algebra 1, we would have just said it's undefined. You can't take the square root of a negative number. But since chapter 4, here in Algebra 2, we were able to define the square root of negative numbers. You guys should remember this. We said that I, the imaginary number, is equal to the square root of negative 1. I squared is equal to negative 1. Well, that's exactly what I'm going to wind up with here. I'm going to wind up with the square root of 16 times the square root of a negative 1, square root of x to the 4th, and the square root of y to the 8th. Well, we can make quick work of this. The square root of 16 is 4. Square root of negative 1 is I. Power is 4, index is 2. 4 divided by 2 is 2, so I wind up with an x squared. Power is 8, index is 2. 8 divided by 2 is 4, so I wind up with y to the 4th power. Again, it's an imaginary number. I wind up with an imaginary number because I'm taking the square root of a negative number. All right, guys, hopefully that little shortcut makes a ton of sense. It's very simple. All you have to do is divide the power by the index, and that will simplify these radicals for you. Head on over to the next page of the notes. We'll try a couple more example problems, and I'll meet you guys over there.